Alright, it's time to review some quadratic equations and functions. So we're going to go through the Chapter 11 review here and hopefully help you understand what's going on if you're having trouble with any of these. If you want to just fast forward to any particular problem, go right ahead, jump around, and hopefully this will help. So here we go. Let's solve some equations. We have a quadratic equation. Notice that there is no x value here, so we just have an x squared. So let's get that 5 to the other side by adding 5. Let's divide by 36. We got x squared equals 536. And we can square root that. And that denominator squares nicely. We always get plus minus when you square root. And so there we have it. Okay, don't forget your plus or minus. And if the denominator is not if it doesn't square out, if it's not a perfect square, then make sure you rationalize the denominator, okay? It's tempting to go ahead on this one, number 2, and square this out, but don't do that. Get this part all by itself, because there's no x's outside the parentheses. Let's get that all by itself. Let's add 6 to both sides. Okay, let's get rid of that 2 there. Okay, get the parentheses squared all by itself. So x minus 6 squared equals 3. And now we're ready to square root. Okay, we want to get this thing squared all by itself. So let's square root to get rid of that. Square root both sides. And we got x minus 6. Don't forget the plus or minus. Square root of 3. We don't know the square root of 3. It's an irrational number. So we're going to leave it like that. Let's add 6. And we've got x equals 6 plus or minus the square root of 3. That represents 2 answers, remember. 6 plus the square root of 3 is one answer. 6 minus the square root of 3 is the other answer. Alright. This guy, well, this one we do want to simplify out. So we're going to have to distribute this. We want to get it in standard form and try to use factoring or something like that. So 4x squared minus 8x. Don't forget to distribute the negative 3x here. Negative 3x squared. Negative 3 times 1 would give you negative 3x. Okay. And let's combine like terms. We got x squared minus 11x. Let's go ahead and bring the 18 over. Going to set equal to 0 because whenever we're factoring, we want to set equal to 0. Okay. And we could use completing the square, but that's going to be too much work. Do we have two numbers now that leading coefficient 1, by the way. So two numbers that add to negative 11 and multiply to 18. Let's see. I think 2 and 9, those are good numbers. So let's go x minus 2 and x minus 9. Okay. And going to use the zero product rule. So we have two things multiplied together that make 0. So one of them has to be 0. Either that is 0 or that is 0. And those are easy to solve. They're not always easy to solve, but sometimes they are, in this case, a lot of times. And so there we have it. Okay? And this one's already in standard form, so we can use any particular method here. Two numbers that add, look for two numbers that add to 2 and multiply to 3. Ooh, they don't exist, okay? So 1 and 3 multiply to 3, but 1 and 3 don't add to 2. So we can't factor, gonna have to use a quadratic formula or completing the square. Let's just go use quadratic formula. Yeah, x equals, let's sing the song, x equals negative b plus or minus square roots, oops, b squared minus 4 AC all over 2a. Pop goes the weasel there, all right? All right, so we get negative 2 plus or minus, and we get 4, and this is going to be minus 12. Let's write that out. 4 minus 12. Just watch out for arithmetic mistakes. If you make a mistake, it's going to be arithmetic most likely. And so this is going to be a square root of negative 8 all over 2. Now we're going for complex answers. So we got a negative in here. So that can be factored out. I'm going to go ahead and write it out, even though we usually don't. It's going to be a negative 1, which will become an I. 8 can be broken up into 4 and 2. Okay? So with that, we get negative 2 plus or minus. This square root of 4 becomes a 2, and the square root of -1 is an I. And the square root of 2 doesn't get to come out and play. He has to hang out inside. All right. Now, we'd like to go ahead and break this up. We can leave it as a plus or minus. That's fine. You need to realize this represents two solutions. Okay, but we're going to take this little I out here. It's the same thing, because this is like I over 1. If you were to multiply I over 1 times this, the I would go up with these guys. 2 times the square root of 2 times I all over 2. That's this part right here. Okay, and we can clean that up a little bit more to get our final answer. Final answer is -1 plus or minus the square root of 2, because these 2's cancel. These 2's cancel. And don't forget the I. I'll put it out here. Maybe we'll put some parentheses there. Okay, that I needs to stay out there, so outside. All right, we'll leave it at that. There you have it. And number 5 here, we got to set it equal to 0. Let's move all these things over this way so that we have a 1x squared. So we end up 0 equals x squared. Subtract the 2x from both sides, and subtract the 5 from both sides. Then we try to factor, but this guy does not factor. Two numbers that add the -2 multiplied to -5 don't exist. So we can use our quadratic formula, which says x equals -b plus or minus square root b squared minus 4ac. A is 1, c is -5, all over 2a. Alright, just be careful substituting numbers in there. Let's simplify it. We get a positive 2, -2 squared is 4. Here we have a -4 times a -5, and the 1 doesn't change anything. So that's going to be a positive 20 all over 2. We end up with 2 plus or minus the square root of 24 all over 2. And we can simplify that. There's a 4 goes into there, into 24. So we have 2 plus or minus the square root of 4 times the square root of 6 all over 2. And that gives us 2 plus or minus 2 square root of 6 all over 2. And remember, this has to divide both of these here. And a good way to remember to do that is to go ahead and break it up as 2 over 2. Put the denominator underneath both of them, both terms there. And these 2's cancel, leaving a 1 behind there. Those cancel, leaving 1 square root of 6. And there's our answer. Two answers. 1 plus the square root of 6, 1 minus the square root of 6. Okay. Moving on to the next one. Again, we look for two numbers that we can add to both sides here, or that we can add the -4 multiply to 8. They don't exist. So we could use the quadratic formula, or we could complete the square. Let me go ahead and complete the square here so we just are reminded how that works. You know, you don't necessarily need to. You could do the quadratic formula, that's fine. But just to review it, we want to get to the x squared plus the bx by itself, get the constant over here. This one's nice for completing the square because there's a 1 there. And so it's not a bad deal when you have 1x squared. So we need to take half of the b value squared. Well, half of 4 is 2, and 2 squared is 4. So we're going to add 4 to this side. What you do to one side, you got to do to the other. And so this one works out pretty nice. This factors into x minus 2 squared, and that's the whole goal of completing the square. And now we can square roots, and we got x minus 2 equals plus or minus. Now this is going to be the square root of 4 we know is 2, but this is -4, so the square root of the negative gives us an I, so it's 2i. Don't forget the plus or minus, and go ahead and do the square root if you can. So we're almost there. Now we need to add 2 to both sides, and so we got it. So completing the square, if you got a handle on it, is not a bad way to go, especially when you have a 1x squared out here, okay? then it's easy. 1x squared, and one more thing that makes it easy if this is even. If this is an odd number, then you get a fraction. So anyways, there you go. All right, this guy here, well, we got to go ahead and multiply that thing out. So we distribute 6x squared plus 6x, distribute the negative 2x, and we get something like this, equals 10. And something nice happens here. Those 6x's go away, and we're left with negative 12x squared equals 10. Let's divide by negative 12, and we get x squared, and that's going to be equal to, I'll see, negative 5, 6. We've got to square root this thing now, so let's square root both sides. Don't forget when you square root both sides that we are going to get a plus minus. That negative on the inside is going to come out as an I, and we have the square root of 5 over the square root of 6. We don't want to leave that square root of 6 down there, so we're going to rationalize the denominator. Don't forget that. Multiply by the square root of 6 over square root of 6, and we get plus or minus. We get the square root of 30, and on the bottom that's going to be 6i. So there is our solution, kind of mixed in there. Okay, so we remember back here on number 3 that we could, the factors give us the solutions. Okay, solutions here come from the factors. So we're going to do the opposite of that now on number 8. If 0 and 7 are the factors, then we have, 0 and 7 are the solutions. We can say x minus 0 and x minus 7 is equal to 0. Then we want it in standard form, the directions say. So we've got to FOIL this. We're going to get, well, first of all, this is just x times x minus 7. We don't need the minus 0, just the same thing. So now distribute, we got x squared minus 7x equals 0. There we go. On to number 9. Same story for imaginary numbers. X minus 9i and x plus 9i equals 0. Got to be equal to 0. Notice, if you plug these numbers in, then it makes 0 for each of the different factors. All right, so we've got to FOIL this out because we want it in standard form. We've got x squared plus 9ix minus 9ix in the middle, and the last two here gives us a minus 81i squared. These guys, the ix go away, and we've got x squared minus 81. Now remember that I squared is worth negative 1. I squared is negative 1. So this is going to be x squared, and that'll become plus 81. Okay? There you have it. All right, so completing the square. Here we want to know what we should complete the square with, and go ahead and do that to factor it. So we take half of the b value squared. So that's going to be 12 divided by 2. 12 over 2 squared is going to be 6 squared, which is 36. And that factors into x plus 6 squared. Here we've got a odd number, so we're going to take negative 5 divided by 2 and square it. We square the top, that's 25. We square the bottom, that's 4. So we got to complete the square with 25 fourths. So when we factor this whole thing factors into x minus 5 halves. It's always going to be that number there. All right, let's go on to the next page. All right, let's talk about the graph of some functions here. We need to find the vertex, axis symmetry, domain, and range. Okay, so the vertex, this is in vertex form, so that's nice. Remember, vertex form is f of x, or y, equals a times x minus h squared plus k. So this is the hk is the vertex. So the vertex is negative 2, positive 4. Always going to be negative or opposite of what we're looking at there for the x value. The axis of symmetry. The axis of symmetry in vertex form, it's just the vertex itself, or the x-coordinate. And so x equals -2. Okay, and so let's go ahead and sketch a picture of this. We know there's a vertex, let's see if I get that straight. Okay, at -2 is our axis symmetry. You don't necessarily need to graph this all the time, but I'm going to just, so we can remember what's going on, I'm going to plot those points there. Okay, let's see. Alright, something like that. And we know the vertex is at -2, +4. Okay, so 1, 2, 3, 4, somewhere up here. Okay, so there's a vertex right there. This -3 here, the a value means it's upside down, and it's 3 times steeper. Okay, so upside down, so we're going to go moving down here in this direction. Normally, from the vertex, we would go right 1, and 1 squared is 1, so we'd go up 1 or down 1 in this case. But we're going to go 3 times as far. So from the vertex, we go right 1. 1 squared is 1, but we want to go down 3. Okay, so we're going to be at a point down here. All right, and we're just doing a rough sketch, so that'll be good enough. It's going to be a parabola, always going to be a parabola. There it is. Okay, and so the domain's always going to be all x values for radical functions. Okay, so it's going to be -infinity to infinity, or you can say all reals. Okay, that's our domain. Our range is going to be, well, it stops. We've got a maximum at 4. So we go from -infinity all the way up to 4. It includes 4, so we need a hard bracket there. Okay, that's what we're talking about there. Okay, I think we got everything we needed. Yep, all right. 13. Okay, this is in standard form. Okay, so we have a couple ways to do this. We can either use the axis of symmetry, and that's x equals -b/2a. That'll give us the axis of symmetry when it's in standard form. Okay, or we can complete the square. All right, this one, well, we're not necessarily told to complete the square, so let's try this. I think -b/2a would be our best route here. Okay, so let's try that. And so if this was a 1, then completing the square would be easy. But let's go ahead and try with the axis symmetry. So x equals -b/2a. A is 2. So that's -4/4, which is -1. Okay, so the axis of symmetry is at x equals -1. It's an equation. You should always have x equals. Okay, now to find the vertex, we need to find the y value, because the vertex is always on the axis of symmetry. So all we got to do is we got to plug in -1 here. -6, and this is going to be 2 times 1. -1 squared is +1, so this is going to be 2. This is going to be -4 -6, and 2 minus 4 is -2 minus 6. That's going to be -8. So when x is -1, y is -8. That is our vertex. Okay. So our vertex is at -1, the x value of the axis symmetry, and -8. Okay, there you have it there. And so we should be able to sketch this. Okay, so we've got our vertex. Let's sketch a graph real quick. Alright, here's my rough little graph, -1, -8, somewhere down here. The a value is 2, so it's going to be opening up because that's a +2. And we're going to go from the vertex, right 1. Normally 1 squared would be 1, but we're going to go up twice as far. The reason why we're going twice as far, because the a value is 2. So we're going to go up to 2. And on the other side of the axis symmetry, our axis symmetry is this thing right up here, the dotted line right there. Okay. If we wanted, we could go find another point from the vertex. If we go right 2, normally we go up 4. but we're doubling it here. So write 2. 2 squared is 4, but we're going up twice as far, so we're going to go up 8 total from the vertex. Always from the vertex. That's all we're doing. When we do these shortcuts, we're just talking about graphing from the vertex or something like that. That's good. Okay, and then so our domain is always all real numbers for a square root function, or square function, sorry. Negative infinity, infinity, and the range is going to be, well, it's going from -8. Put some numbers on your graph always. Shame on me, I almost missed that, to infinity. -8 to infinity. Okay? All right. So those are domain and range. All right. This guy here, you know what? Before we leave that, I want to show you completing the square with this. All right. This is a good one. Let's practice that. Okay. Let's complete the square just for some good practice. So I'm going to change it into y for now. So we have this. We want to take that -6. We tuck it away. We're going to factor out of these two. We're going to factor out of 2, leaving us with x squared plus 2x. I'm going to leave a little space here. I'd like this to be a perfect square, so we're going to add half of this squared. Half of this squared is 1. This actually turns out to be a pretty easy one. But remember, we got to take it away also. So there's a little twist with this. Okay, so y equals 2. Oh, get that out of there. That's on the outside. Now we got to get this -1 outside, but remember it gets doubled. That's what this 2 is all about here. So we've got x squared plus 2x plus 1, and then we're going to take this -1 out here, but it's going to get doubled because again it's this -1 times this 2. Positive 2 times -1 gives us -2. Okay, well that wasn't hard at all. And so, but we're almost done. We just got to factor this parentheses. So we have y equals 2. The parentheses become x plus 1 squared minus 8. There's vertex form. Okay, so 2 routes to go to find the vertex. We can find the axis of symmetry. Then plug it in, that's the x value, plug it in to get the y value. Or we can complete the square. Okay, and when we complete the square, we factor it. And we have some constants left over out here. Notice the vertex is at -1, -8. And the a value is 2. So everything's right there. All right, let's look at the next one down here. We need to find the vertex here. Okay. In this case here, completing the square is going to be a little tricky, but it's actually just as easy as, well, not much more challenging than plugging the -b over 2a in. All right, so let's go ahead and complete the square. So -13, we're going to factor out -2. That leaves x squared minus 9/2 x. And convince yourself that that's the same thing there. Okay, so -2 times 9, -9 gives us positive 9x. Now, the tricky part is what goes in here. Well, it's going to be half of 9/2 squared. And half of 9/2 squared, well, that's going to be 9/4 squared, which is 81/16. So we're going to add 81/16. And we're going to subtract it. Same process. Just got a fraction. All right. Now, this, we're going to leave most of it in there. And 81/16. This guy has to come on out. But remember, it's 2 times that. -2 actually times that. Alright, so -2 times this, it's actually going to cancel this out. If you want to think of it, this is 2 over 1 times 81, that's 162/16, and that fraction is going to simplify to just 81/8. Basically, this 2 divides that by 2. Okay, no fraction stuff there. Minus 13. Well, this right here is going to factor, guaranteed. It's always going to be half. It's going to be that number over there. No, this one over here. This one over here, 81/16. So it's going to be 8. I'm sorry. It is not that one. It's this half. It's half of 9/2. It's that 9/4. Always going to be, and actually though, it's going to be a minus because of this minus right there. All right. This is a challenging one. Okay. 13. Let's make that 13 is how many eighths? We've got 81/8 and minus 13. 8 times 13 is 104, I do believe. So that becomes that. Okay. Putting these together, I'm going to get negative 23. I think that's it. I think so. Okay. So there we go. Our vertex is at 9/4. Beautiful. Negative 23/8. All right. So there's our vertex. We found it. Our axis of symmetry is x equals 9/4. Okay. This one's going to be just a bear to graph, so we're not going to do too much with this. 9/4 is about 2 and change, and negative 23/8. 8 times 3 is 24, so that's about negative 3. So we're talking about positive 2 and negative 3 roughly, and it is opening down because of that negative 2, and it's going to be a little steeper. So okay, not going to make you graph that on a test. All right. So anyways, the domain is all real numbers, negative infinity to infinity. The range is going to be below, whoops, so it's going to be negative infinity all the way going up to that negative 23/8. Okay. All right. That's kind of a tough one. So, all right. Now we need to find the x-intercepts, y-intercepts of functions. Write them as ordered pairs, okay? Remember, to find the x-intercept, plug in 0 for the y's. To find the y-intercept, plug in 0 for the x's. So the y-intercept's easy. That's g of 0, which is 2 times 0 squared, plus 4 times 0 minus 6, which is just negative 6. Okay? So there's our y-intercept. Our x-intercept is going to be by setting 0. Oh, let's hold on a second. Let's make this an order pair. 0, negative 6. There's our y-intercept. Okay? And now we need to find out what x is. Plus 4x minus 6. Okay? So we can use our quadratic formula. Good idea to do first here, though, because we can, because we're setting equal to 0, is divide everything by 2. So if we divide everything by 2, we get this. Oh, look at factors. That's nice. Two numbers that add to 2 and multiply to negative 3. I believe those are plus 2 and minus 1. So we get two solutions, x equals negative 2 and x equals 1. So that would be our x-intercepts. There's 2 of them. And our x-intercepts are going to be at negative 2, 0, and 1, 0. Those are the two x values that make y 0. Alright? Alright, so cruising along. Let's find the y-intercept. So we have negative 2 times 0 squared plus 9 times 0 minus 13. And that's going to be negative 13. So our y-intercept, the easiest one to find, is going to be 0, 13. And now, to find the x-intercept, we plug in 0 for y. And we're going to solve this up. No factoring. I don't think factoring is going to go here. I don't know. It might. AC method, this would be positive 26 if we multiply that. Two numbers that multiply to 26 and add to this. No, I don't think so. 13, 2, no, not going to happen, okay? So we got to use our quadratic formula. And so we have x equals negative b plus or minus square root b squared minus 4ac is negative 2, b is negative 13, all over 2a. Okay, so we get 81, and this is going to be a negative 4 times 2 times, it's negative because we got a negative times a negative times a negative. That's a negative. All right, and so 8 times 13, that would be 80, and oh, we just did that, 104, right? 104. Well, we're going to run into a negative number underneath here. Remember, that's our discriminant. So plus or minus, and we've got the square root of negative 24, and that tells us that there are no real solutions. Since there's no real solutions, there's no x-intercept. We can stop there because the question asks us to find the intercepts, and we found out that there is none. Okay, so what that means is that we've got some kind of parabola going on here. Oh, I don't know exactly. It's gonna, whoa, that's it's gonna be upside down because that negative 2, it's something down here, but it doesn't cross the x-axis at all. There's no solutions to that, no zeros, no x-intercepts. All right, almost there. A couple more here. We're going to solve for the variable that we're given. All right, so 17 here. We want to solve for r. That's what we're going for, little r, that is. So let's get all this stuff out of there. Let's multiply everything by 3 first of all. Let's get rid of that 1/3. So we got 3v equals 3 times a third is 1. Okay, r squared plus little r squared. And let's just kind of work our way down to get that little r squared. So let's divide by pi, get the pi out of there. You could distribute it, but I think that's just going to cause more problems. Let's just divide it. And we got r squared plus little r squared. Let's subtract this big R squared. Okay, subtract that from both sides. We get 3v over pi minus r squared minus, whoops, let's just say plus r equals r squared. We were trying to solve for r, so let's square root that whole thing. So we're left with r equals a big ugly square root, 3v over pi minus big R squared. There is our solution. Okay, so we solved it. Get another crazy looking function, but that's the idea. Okay, all right, so t here, this one now we have a number in, or the variable we're looking for is t. Don't worry about the a. Think of that as a constant. Think of this as 20 or 2a, all right? It is 2a. So just think of that as a number. And the t is the variable we're looking for. Now, the challenging part here is that t, we have t to the first, we have t squared. So this is a quadratic equation. So let's move these guys over here by subtracting. Set equal to 0 because it's a quadratic equation. And we get minus t minus 2a because we subtracted that from both sides. Now, oh, I forgot a square. That's 3t squared. So again, we can't simplify this or anything. We can't factor it, I don't think. No, we're not going to be able to because of the a. Just treat that like a number. Okay, so we need to use the quadratic formula. And instead of x equals, it's t equals, because notice the t is in the x spot. So t equals negative b, and b is this negative 1 that's right here. Plus or minus the square root, and b squared, well, b is the negative 1, minus 4 times a times c, all over 2a. Okay? So we get positive 1 plus or minus the square root of 1. That whole business is going to be 12 times 2, that's 24. 24a, all over 6. Okay? And t equals, that's all we can do. Okay? So we're just asked to solve for t. We're not going to get a number for it because that a is not going anywhere. It's not going away. So we got to leave it there. All right. Almost there. LeBron James reportedly is a vertical leap of 44 inches. What's his hang time? Here's an equation. Use V. Now we're not told much about this on a test. I would tell you. T is time. V is the vertical jump. All right. So we've got a 44-inch vertical jump, and that's almost 4 feet. He can jump in the air. Amazing. We've got to solve this equation. So let's divide by 48. Divide by 48. And 4 goes into both of those. So that's 11/12. And we got t squared. Got to solve it by square rooting. And so t equals the square root of 11/12. Now this is an application problem. Directions didn't tell us what to round to, but we are going to want to round. That's fine. Okay, so this is going to be in seconds. All right. So let's go to our calculator and figure that out. And we get about 0.957 seconds. All right. So that's the idea there. Okay. A little application of quadratics. All right, last ones here. We got some application problems. So we have number 20. The number of pounds of milk per day recommended for a calf that is X weeks old can be approximated by this function. What's the calf's milk consumption? When is it the greatest, that is? And how much milk does it consume at that time? So here's our function. It's a parabola because it's x squared. All right. Notice it's upside down because of the -2. So we've got some graph, all right, like that. And we want to find out what the maximum is. So we're just finding the vertex. That's all we're doing, okay? Now you can do this a couple ways. You can graph it and get the vertex. I'll try that. Graphing it, we look at something like this, okay? And we've got that graph has a vertex at positive 3.25 and 8.3. So the maximum value there is 8.313, all right? And so that gives us our max. So at 3.25 weeks, that was the 3.25. That was the x value. The y value is 5.313. Okay. So the max is 5.313 pounds. All right, at 3.25 weeks. Okay, so we found the max there. We could also, let's tuck this away here. We could also have found the vertex using negative b over 2a. X equals negative b over 2a. And that is negative 1.3 over 2 times negative 0.2. And that's going to give us, if you work that out, 3.25. Okay. And so then plug that back in, and you're going to find out that y, or p of 3.25, is going to be the 5.313. So you can find the vertex that way too. All right, 2 ways. Here we got a similar idea. We're going to, publishers trying to minimize the average cost per books per printed. The average cost is given by this function, where x is the total number of books in thousands printed. What is the minimum cost per book, and how many books should they print? Okay, this is a quadratic formula, so it has a minimum. Again, we could graph it. Let's try that real quick. When we graph it, here's a graph that we get, and here's our vertex, negative 2.33 and 25. So 2, why did I say negative? I'm sorry, it's getting late. 2.333 and 25.9818. All right, so there's our vertex. By the way, if you're doing this on a test, you should sketch it out and kind of give some idea of where these numbers are coming from. You're not just making them up. And so there's our vertex. So we could say, what's the minimum cost per book? Well, we can say that the cost is $25.92 per book. And this is at 2.33 thousandths of book, right? It says in thousands. Or multiply this by 1,000, which moves the decimal over. It's 2,333 books. Okay? So that's going to be the cheapest price at this function. All right? So that's a graphing method there. You could also find the, there you go, you could do the negative b over 2a there also. All right, we'll do one more. I'm going to skip the regression one for right now. This fence problem, here's the idea of this type of problem. Ginger's fencing a rectangular fence using one side of her house. So here's her house. Okay, here's her little door to her house, and here's her little window, so on and so forth. Okay, so she's got her house, and next to her house, she's going to fence a rectangular garden, all right? And so we want to know the maximum area if we have 40 yards of fencing. Okay, so here's the thing. The thing is that if this is the width of our rectangular garden, the fencing that we have to go all around this total garden is W wide. I don't know how wide it is, but I know I have 40 yards of fencing, so for the length here, I can take 40 yards, and I can take away 2 W's. That's how much fencing I will have for this length. If W is the unknown width, then this has to be 40, because I only have 40 yards of fencing, minus 2W. So the area here is W times 40 minus 2W. Okay, and I want this to be a maximum. Now this is actually a quadratic function, because if you distribute this, you have 40W minus 2W squared. Okay, and so that is a parabola, and it has a maximum. Let's actually put this in standard form. 2W squared plus 40W. There it is in standard form. Let's do our negative b over 2a, the axis of symmetry. The axis of symmetry is a way to find the vertex. So negative b over 2a. And so b, when we put it in standard form, is this 40 here. So we have negative 40 over 2 times a, which is negative 2. So that is negative 40 over 4, if I can write. So we've got negative 40 over 4 negative, which is 10. So when the width is 10, we get a maximum. Okay? So the question is, that's our width, by the way. What should the dimensions of the garden be? Well, if the width is 40, the length is 40. We get it from over here. The length is 40 minus 2W. So the length is going to be 40 minus 20, which is 20. And if you add that up, that'll be 20 by 10. That'll be 40 yards of fencing. Okay? Because remember, we're not fencing along the house. That's the key. We're not fencing along the house. Okay, we're going to skip this regression one for now. Hopefully that helps there. Gives you an idea on how to do some of these problems.